How are you, my friends? Here we are continuing the algebra course lectures, and this is lecture number 14. As I mentioned in the other lecture 13, the lecture 13, 14, 15, they will cover rational expressions. So this is lecture 14, where we add and subtract rational expressions. And for sure, we have to use the idea of least common denominator, LCD. We will see simple, medium, difficult questions. Now, just to remind you, what is a rational expression? It's a polynomial divided by another polynomial. And the main idea in these sections, we have to use factoring. All right, let's start with adding, subtracting rational expressions, but we have same denominators, which is so easy. No LCD needed. If, you can see here, if the denominators are the same. So we have P over Q plus R over Q. Q is the same, no problem at all, leave it, P plus Q. Also, we have subtraction. P over Q minus R over Q, same denominator, leave it, subtract. That's a simple example. 8x over x plus 1 plus 8 over x plus 1. The important part in this question, x plus 1. This is denominator 1, denominator 2. They are the same. If they are the same, directly we go and add. 8x plus 8. How do we add 8x plus 8? We cannot add, but we take 8 common factor by factoring, then we cancel x plus 1. The answer is 8 here. Now, suppose we have 8x plus 7. Then we cannot do anything. Just leave it. 8x plus 7 divided by x plus 1. Now, this is so easy, and we take also easy example. 2 parts. Easy example, a plus b over 4ab plus a minus b over 4ab. This is the, see, we can see here, this is addition, this is subtraction, where we have the same denominator. Let's take the first one. I think it's so easy to figure out. 4ab is the same, directly you can add. See, this is the same, directly you can subtract. Now, there is a little trick here you have to be careful of. You have a minus, and then there is here 2 terms. In this expression, when you have a minus, you have to change all the signs. Again, this minus, you have to change all the signs. Be careful. Now the first one, since we have the same denominators, then we can add directly. A4AB, we write it down. See, 1, 4AB, we write 4AB. Remember that. We don't add these, we don't multiply them, nothing. 4ab. So we put a plus b plus a minus b. Same. Now minus b plus b, they cancel. A and a, 2a. Now we start to cancel. You cancel the a, you cancel the 2. So there is a 2, and b 1 over 2b is the answer. So easy. You can try second one. So simple. Minus 2x over x plus 2y minus, subtraction here, x plus 6y over x plus 2y. And I want you to compare these simple questions with the difficult ones after a few minutes. Let's see the second one, subtraction. So we said the denominators are the same, so we can subtract. Listen here, how do you subtract? Minus, x with the minus. There's a plus 6, becomes minus 6. If you have a minus 6, then becomes plus 6. Because of this minus, you change all the signs after that, in the numerator only. Now we have minus 3x minus 6x. Let's take minus 3 out. Then we have x plus 2y, we can cancel. Sometimes we cannot cancel, see? We just leave it. Suppose we have x plus 5y over x plus 2y, just leave it. But here the answer is minus 3. Try at home, as I mentioned, try at home, extra questions, practice. You can always find them in another video called Additional Solved Questions, Rational expressions. All the solutions in details. See, I put here the question and then the answer, the question and then the answer. Now let's go to LCD. This is so much important in mathematics. The idea of LCD. The meaning is the least common denominator. So when you are adding fractions or subtracting fractions, where you have a different denominator, then you have to find LCD, which will be the same denominator for both. Now, 2 steps only to find LCD. Factor each denominator completely. I will show you many examples. After you factor each one completely, the LCD will be the product of. That means you have to imagine that you need to multiply things, numbers, brackets, factors. You have to multiply everything there in the question, but each one should be a prime factor. You see, product. Product means you multiply something times something times something, maybe 2, maybe 3, maybe 4, maybe 5. Multiply all these prime factor, each one raised to its highest power. Let's look at this simple example. 3 fractions we have, very ugly denominators, 3 over 2k, just listen carefully please, 7 over 10k squared, 1 over 12k cubed. How can we add these 3 rational expressions? Now first, before I do anything, I have to find LCD. So I don't care about 3 and 7 and 1, positive or negative. I look at 2k. 2 is prime, k is a number. So let's say prime, so we leave it. 10, oh, not prime. So we break it down. 2 times 5, k squared, we leave it because it's 1k here. 12, 4 times 3. 4 is not prime. You know prime numbers we have seen in real numbers. It's a number that can be divisible by 1 and itself only. So 12, I can write it as 2 squared times 3. So these are prime. And there is k cubed. Now look, I did now break down the numbers. Then I have to figure out the LCD. LCD. I have a 2, and then I have a 2, and then I have a 2 squared. Each number, I take it 1 time. See, it says here, each different prime number, 1 time, highest power. 2 squared, I take 2 squared. There is no 5 here, there is 1 5, and there is no 5, the highest power is 1, take 5. There is no 3, 3, I take 3. This 3 from the denominator, I don't care about 3 and 7. Now I have k squared, k cubed. So I deal with k as a number, k cubed, I take the highest. Now easy to multiply. 2 squared is 4. 20 times 3, 60k cubed. Now I have to make this one 2k, 60k cubed. Then I have to make 10k squared, 60k cubed. Then I have to make this one 60k cubed. Then I will add and subtract. This slide will tell you, this will summarize simple, medium, difficult, complicated, challenging questions about how to find LCD. Now let's see. Look at this nice slide and nice colors. The whole slide, this one, you can see this in the video algebra course lecture 2. Back. If you need to see this exact example. But why I'm putting this slide from video on algebra course lecture 2? Because these are lecture 2 here, rational numbers. You see this nice color here. Lecture 2 is rational numbers, fractions, 2 over 3, 7 over 10, 3 over 8, etc. Finding LCD. Same idea. Lecture 14. Now, this lecture we are doing, we have rational expressions. So maybe instead of 3 over 8, we have x over y, a minus b over a plus b. Okay, so you can review this example here. 3 over 8 plus 7 over 10 minus 1. You can go to the video on lecture 2. 8 is 2 cubed, 10 is 5 times 2. I take the highest power, so 2 cubed and 5. 40 is the LCD, make this one 40, make this one 40, make this one 40. See the one here, minus 1? I multiply 40 over 40. I have to make all 40. When you add and subtract, you get 3 over 40. Is the answer of this, believe it or not. Now we will do the same. This is only like to refresh your memory. We have to do the same, but for x and y. Also, I'm starting with 4 done examples. Suppose we have 7 over x and 5 over y. I'm not saying here add or subtract. See the idea here, how to find LCD. Now this example here from lecture 2, this is a complete example, adding, subtracting. This example here, done example, to show you if you have 2 fractions like this, 7 over x, 5 over y. See x and y, they are variables, so we multiply them. So that's the LCD. Now 7 over a, another example, 5 over a squared. We don't multiply them. Aha, that's the story. We don't multiply a and a squared because it would be a cubed, but a squared is the least common denominator here. Why? Because a and a is the same number and we take the highest power. Now let's look more example here. 7 over 3 ab power 5, 5 over a cubed b squared. What is the LCD? So 3, there is no 3, I take the 3. It should be included in the LCD. A and a cubed, I take a cubed because the highest power. B power 5, b squared, I take the highest power. So that is the LCD. Now how to use it? We will see next examples, many examples actually. Let's see more. 1 over x minus 2, 3 over x plus 5. Suppose I need to add or subtract. So x minus 2, how do you find LCD? X, we know x is a variable. X minus 2 also is another variable. So x minus 2 is a number by itself. See, like this one here, you see x times y. X plus 5 is another number. Even if you have x and x, we cannot say here x squared or whatever. So we multiply the x minus 2. That's new number. X plus 5 is another completely different number. So x minus 2, x plus 5 is the LCD here. You have to practice so many questions on the LCD to be expert. Also this example 5, we need find only the LCD for these fractions. Complicated, I'm sure. I did not say add or subtract. I can put here plus and I can put here minus. It will be a very long question. We will see one like that. But now I need to concentrate on the idea how to find the least common denominator. Okay, so what do we do? What is the first step? Remember that? First step? You want me to go back? I think you can do it. First step, factor each denominator completely. This one factor it, this one factor it, this one factor it. Sometimes if you have an exam, maybe this is a question. Find only LCD. That will be the answer. Okay. Sometimes we say add and subtract. So you find LCD, then you use it to add and subtract fractions. Let's see this nice question. I explained that in 2 slides, actually, just to explain it in details. That's the given. So what is the given? 3 rational expressions. Factor each denominator slowly and easily. 15, we take it out, a minus b. 9, we take it out, a squared minus b squared. 2, we take it out, a squared minus 2ab plus b squared. Now it looks very lengthy, it takes time, but this is the way to do it. You can do it faster when you are expert. 15, 5 times 3. See, I didn't care about 2, 7, or 3 numerators. A minus b, 9 is 3 squared. This is the difference between 2 squares, a minus b, a plus b. 2 is out there, and this is a perfect. You see perfect? Squared trinomial, a squared minus 2b plus b squared, a minus b all squared. Now ready. Let's go. LCD, the product of prime factors, each one raised to its highest power. Now, before we go to the next slide, I hope you can pause the video for a minute or two, figure out from these numbers what is the LCD. You have to product, you have to multiply things. I can help you here maybe. We have 5, we have 3, 3 squared, and 2. See, this is the only 2 we have, so we have to include the 2. 3 and 3 squared, we take the highest power. Only we take 3 squared. And then look at the others here, like a minus b. You see a minus b, we have a minus b. We have a minus b squared. Which one we take? Only the highest power. So the whole LCD will be 5. There is a 5 here. See, this is from the last slide. I put also the definition here so that you can review it. So the LCD will be the 5 by itself, the highest power 3 squared, 2, a minus b squared, a plus b, because we have a plus b 1 time, a minus b we have 3 times, but we take only the highest power. So that's 90. Just make it simple. See, this is big, simpler. That's the best answer here. 90. A minus b squared times a plus b. This is the LCD for these fractions when you need to add and subtract. Okay, let's see. Try at home. Another example. Try at home. You can do it. 7 over 4m squared, 5 over this, 1 over 10m cubed. Factor it, find the LCD. The answer is there actually. If you need the whole complete solution, please see additional solve questions. Now, here when we have different denominators, we need to add and subtract. I explained everything about LCD. Now we need to use it. Use the LCD when we add and subtract. Remember all the examples, all the explanations before this slide, how to find it, the LCD, how to find it. Now we have to use it. I will give you 2 nice examples. Second one is more lengthy, more work in it. First one also. Perform the indicated operations. 2k over k squared minus 1 over k plus 1. I can put the minus here if you like. See, I can put the minus. That's easier question than this. We will do both in details. Now, one by one, let's add here and subtract here. Okay, go to the first one. Example 6, part 1. What do we do? What do we do? Find LCD. Why we find LCD? Why we think of LCD? Because the denominators are different. Here, the denominators are different. I cannot multiply these two. Remember, I cannot multiply them. I cannot multiply this and this, as many students or math users, they do. That's wrong. Now, what can we do? Factor each denominator to find the least. It's better to find the least common, not any denominator, the least. Let's go the first one. Takes 2 slides, maybe just to explain it in details. So 2k, k squared minus 1. Factor first all denominators. See this one, 2k, k plus 1, k minus 1. We know that difference between 2 squares from the factoring. K plus 1. Okay, so this is k plus 1, 2k over k squared minus 1. Yes. Now let's look at the LCD. We have k plus 1, k plus 1. Both are power 1. I take the highest power. So one of them, k minus 1, I have one of them. So I take k minus 1. So now the product without the squared, remember? Because the highest power here is 1 in each. So that's the LCD. Now, see how do we use it? Please, this is easy to find LCD. Now, how to use it? We must make all the denominators the same. This one is not the same, but we use this one factor, do you see? Now forget about the question. Look here. K plus 1, k minus 1. This is only k plus 1. I have to make it the same to add. So the only thing I can do, leave the first one, multiply up and down, see, multiply up and down by the factor from the LCD to make it the same as the LCD. See, what's missing here? K minus 1, so up and down should be, it's like 1. So now 2k over this, minus 1 times this, k minus 1 over this times this. That's a product. Now we continue in the next slide. It's easy now. Same denominator. Here we have 2k. Here we have minus 1 times k minus 1. Let's continue now. See this one from the last slide. So minus 1 times the k is minus k, minus 1 plus 1. See, we have now the same. You see, it's same. We made the question the same. It was not the same. So we write only one LCD here, k plus 1, k minus 1. So we have 2k. Remember, if there is a minus here, I told you before, if there is a minus, you change the signs. But since we don't have a minus, it's a plus. So I write minus k plus 1. I can add like terms. Always I have to simplify. 2k minus k is k plus 1. I can cancel k plus 1. And then the answer 1 over k minus 1. Suppose I have here k plus 5. Just leave it. You cannot do anything. If you have k plus 5 or k plus 2 or k minus 3, any number other than 1, if you cannot cancel, leave it. Now, I hope, good idea here is to do number 2. Take a minute or so, factor each denominator here, find the LCD, and then try to subtract. Ready? Let's go together. I think it's 2 slides also. Yeah, 2 slides. Okay, let's take half of it. I will factor all the denominators here. 2x, x plus 3, x plus 2. This is easy. That's a trinomial. Remember, if you need the factoring rules, you have to go to lectures 10, 11, and 12. All kind of factoring. Here we have a trinomial, the leading coefficient 1, so x plus 3, x minus 1. Just look at the denominator, see what is the LCD. Now we have x plus 3, same factor here, and the highest power is 1, so I take it 1 time. X plus 2, I take it 1 time. X minus 1, 1 time. If we have different powers, remember, different powers, take the highest. Now make all the denominators the same. Look here, very nice how to make the denominators the same here. Now this one, x plus 3, x plus 2. You see this one? What's missing from the LCD? X minus 1. So I multiply up and down. Up here, down here. And there is a minus in the question. Second one here, x plus 3, x minus 1. What's missing to make it like the LCD? We found LCD to use it, guys. We did not find LCD only to look at it or take a picture. See, this is nice colors here inside. We found LCD to use it in the question to make these denominators the same. So what's missing here? How to know what's missing? If you like, take this in your head, this LCD, divide by this denominator. So it's easy to find x plus 2. So multiply and up and down. See, up here, down here, by x plus 2. Now we have on the next slide, we will see the same denominator. But remember, multiply 2x times x minus 1. Multiply x plus 1 times x plus 2. And there is a minus here. So it's a story. Okay, did you try? Let's see. Now, when you multiply 2x times x minus 1, as I said from the last slide, minus, there is a minus here, multiply x plus 1, x plus 2. So this will be 2x squared minus 2x. And see the minus here, in the bracket we multiply, we have to change all the signs. Remember we said that this is like subtraction. So minus x squared minus 3x minus 2 over the LCD. Now we know what is the LCD here. I just wrote LCD to save time. Then at the end, you have to write the complete answer. You can write here sometimes LCD. We know what is the LCD, just to save time and energy and typing. Then at the end, you can write the final answer. Now, x squared, 2x squared, and the minus x, there is x squared, minus 5x minus 2. There is no factoring for this, unfortunately, and then leave it, but you have to write the LCD. That's the whole answer. If you write this as the answer, that's wrong. If you can factor, factor. Okay, now here the leading coefficient is 1. Find two numbers, their sum is minus 5 here. The leading coefficient is 1. Two numbers, their sum is minus 5. Their product is minus 2. There is no integers like this, so we cannot cancel. Just leave the whole answer. Now, 3 nice questions. Try at home 6 again. I will say try at home. I will put only the answers. Yes, this is the answers of these 3 questions A, B, C in try at home 6. If you need the complete solutions of these try at home and practice, you can find them in additional solve questions. Now this topic is to be continued in lecture 15 because we have 13, 14, and 15 for rational expressions. Thank you for watching. If you like the video, you can subscribe, share, and then just to remind you, this is lecture 14. Thank you very much.